The Higgs Boson particle is an elementary particle in the Standard Model. Why he matters? Because he explained why certain particles have mass, and particles like photons have no mass. No Higgs Boson. Electrons would have no mass. Atoms can't form. We wouldn't exist. So, how did we discover this elusive particle? Let's go back in time to 1964. Then Peter Higgs and Francois Englert came up with a groundbreaking solution. Higgs mechanism. Imagine that. You are at a party. Everyone is socializing. Now imagine everyone at the party is an example. And the room itself is the Higgs field. The Higgs Boson is like the guy who's leading the dance. Make everyone dance in a certain way. This motion is what scientists believe gives particles mass. So let's just say that there is a factory that charges the entire universe. This is the Higgs plant. Particles gain mass through interactions in this plant. The stronger the interaction, the heavier the example. And Higgs Boson, he is the quantum manifestation of this field, or excited state. For decades, this theory is just a theory, but still. This theory is so convincing, so much so that in 2013, Peter Higgs and Francois Englert won the Nobel Prize in Physics. Their work laid the foundation for one of the most important scientific traces in history. But how do you prove the existence of something as elusive as the Higgs boson? And that's what makes this story even more exciting. Let's go to Box, Europe. The largest building in the world was built there, the most powerful particle pairing machine. Only after finding this particle, fast forward to the early 2000s, the stage is ready for the arrival of large hadron pairs. This huge machine is buried deep under the Franco-Swiss border, designed to hit the child at nearly the speed of light. The hope is that if you make a strong enough collision, can break protons. Let's get a glimpse into the secrets and create the conditions for scientists to detect the Higgs boson color. A team of the world's brightest physicists use state-of-the-art modern technology to capture this moment in time. And these find and record data are the tools that they use to study this phenomenon. July 4th, 2012. The truth comes out. Alice and the CMS experimental team at the European Box Research Center have announced the discovery of a drug with absorption, a new example of Higgs boson SWAT. This finding confirms the existence of the Higgs field. From that moment on, our understanding of matter and the universe will change forever. This monumental discovery is the result of decades of theoretical work and experimental innovation. So what makes Higgs boson so unique? Let's delve into his attributes and characteristics. Understand why this example is so important. First of all, a Higgs boson particle is a scalar particle. That means he didn't choose. So we talk about self-selection in particle physics. It's very different from the way we think of spin. We're not saying that particles spin around like ballerinas. Higgs boson is the kid who can't spin. It's called spin because this property is similar to what we see in rotating objects. Most elementary particles, such as electrons and quarks, have a property called spin. It's a form of internal agitation, but Higgs boson is different in color. It's the only one in the Standard Model that doesn't have a choice. The other unique characteristic of the Higgs boxers is his mass. The mass of the Higgs boson at the time of its discovery was approximately 1.78 x 10 square kilograms. This quality is very important. It fits perfectly with the Standard Model. Now let's talk about his decay. Higgs boson is very short-lived. Almost as soon as it was created, it will decay into other particles. These patterns of decay, the way the Higgs boson is broken down, is what scientists look for in their data. For example, he could decay into the photons Z Poseidon. There are even some examples we haven't found yet. Each decay path. Both help physicists learn more about the Higgs field and its interactions with other particles. These unique properties are more than just scientific curiosity. They provide important clues about the fundamental structure of the universe. But the Higgs boson is more than that. He also had a profound impact on our understanding of the Standard Model. So let's talk about how this fits into a broader picture. This discovery is like finding the missing piece of the puzzle. For decades, physicists have been using the Standard Model, which is the framework that describes the fundamental particles in the universe. It's been very successful, but there is one obvious flaw. They couldn't explain the mechanism by which particles are given mass. The discovery of Higgs boson finally completes the standard magic piano. The Higgs field explains why particles like electrons and quarks have mass. Make the Standard Model more accurate at predicting the behavior of all known examples. That's a tremendous achievement, because he validated years of theoretical work and confirmed that our understanding of the smallest scale universe is correct. But Higgs boson is not just confirmation of pre-existing theories. His discovery opened up new avenues of research. It raises new questions. For example, why does the Higgs field have a particular strength? Are there any other undiscovered particle disasters? These questions push us beyond the Standard Model, implying that there's more to this underlying reality that we need to understand. This issue had far-reaching implications, not only for particle physics, and to our understanding of the universe as a whole. As we continue to study Higgs bosons, we will reveal more secrets about the fundamental structure of our existence. So in this exciting field of research, what will the future hold? One of the most exciting prospects is the development of a new type of collider project. The Large Hadron Collider is already a discovered power source, but scientists are already planning for his successor, the Future Ring Collider. This next-generation collider will be even bigger and more powerful, capable of reaching energies far exceeding those of the Large Gun Collider. With the Future Ring Collider, physicists hope to delve deeper into the properties of Higgs boson particles and explore potential psychophysics beyond the Standard Model. Another promising direction is to study the interaction of Higgs boson particles with other particles. Researchers are particularly interested in rare decay patterns and interactions. This could all be a hidden aspect of the Higgs field, even new examples. These investigations could shed light on some of the biggest questions in physics, such as the properties of dark matter and the imbalance between matter and antimatter in the universe. In addition, it is also crucial to accurately measure the characteristics of the Higgs boson. By improving our understanding of its quality, Understanding saturation intensity and decay modes, scientists can test the standard model, limits, and look for any differences that might suggest new physics. The future of Higgs boson research is full of potential. Every new experiment and observation makes us more radical. Answer fundamental questions about the universe. As we build more advanced colliders and develop new technologies, the mystery of Higgs bosons will continue to be solved. Produce discoveries that could reshape our understanding of reality. Finally, let's wrap up what made Higgs boson such an important discovery. Why does he continue to attract the attention of the scientific community? And Higgs boson is not just one of these subatomic particles. He is the bedrock of our understanding of the universe. His discovery marked the completion of the Standard Model, an explanation for how particles acquire mass, and validated decades of theoretical predictions, theoretical foundations laid in the 1960s. Breakthrough experiments at CERN by 2012. Uncovering the journey of Higgs bosons was a huge scientific undertaking. The characteristics of Higgs bosons, for example, its unique mass and decay pattern, opens a new window into the workings of the universe, reveals the complex dance of the example dominated by the Higgs field. But the excitement doesn't stop there. The future of Higgs boson research is promising. New collider projects and precise measurements promise to further expand our knowledge. These efforts will not only enhance our understanding of the Higgs bosons itself, it may also be that new physics answers some of the deepest questions about the nature of reality. Today we explore what happened to Russia's first moon mission since 1976. For a country that was far ahead in the space race, what's the problem? Although we often see reports about NASA or European Space Agency missions, but Russia's space program is just as impressive in history. In 1957, Russia launched the first artificial satellite, Sputnik Luna 15. It kicked off the space race. The Soviet space program was flourishing. The Soviet Union not only sent the first male and first female astronauts into space, and completed the first multi-person spaceflight, launched the first dog into space, escaped the Hell system for the first time, first impact on the moon, first orbital flight, the first photos taken of the far side of the moon. Russian cosmonauts also completed the first spacewalk in human history. Russia also launched its first space station. This series of achievements not only attracted the attention of the world, it also makes the Russian leadership feel extremely proud. It seems as if Russia is winning the space race, but beneath the glossy surface, things were not so smooth sailing. The Soviet Union had its share of tragedies in space exploration. For example, the astronaut Vernaki Merkamurov was killed when the parachute of the return capsule failed to open. The 3 who died in space were all Russian cosmonauts. They were visiting the first ever space station. Despite the repeated failures of Russian launch missions, but for external image reasons, especially to look more glamorous compared to the competition in the United States, Russia has barely publicized any failed moon landing attempts. In fact, only about 34% of Russian lunar missions have been successful. In the United States, the corresponding mission success rate reached 60%, In 1969, the United States sent a man to the moon for the first time. After achieving this feat, both superpowers seem to have lost interest in continuing the race. And in the mid-1970s, it shifted the focus of its space program to non-lunar exploration missions. Soviet astronauts never set foot on the moon. The Soviet Union canceled all relevant plans. Part of the reason is that it was considered a costly endeavor. But here's the thing. If you could only be the second country to land on the moon, so what's the point of such an effort? However, at the turn of the century, the world's interest in going to the moon has been reignited. Scientists are beginning to realize the moon is not only rich in resources. For example, the newly discovered Sailor machine is suitable for use as rocket fuel, sources of air and water, and its low-gravity environment makes it an ideal springboard for a manned mission to Mars. The potential value of lunar resources began to attract the attention of global businesses. Governments are also considering establishing permanent bases on the lunar surface. Think of it as a means of making money. Of course, there is still a lot of scientific research done on the moon. These studies have attracted the hope of gaining a deeper understanding of the moon's formation process and its impact on Earth. Scientists affected by the lunar cycle. In this context, Russia's old rival, the United States, has also begun to restart its space exploration program. The United States launched the Constellation project in 2005. Its stated goal is to return to the moon. In addition, other countries are also starting to join the space exploration race. Although India did not participate in the first race to land on the moon, but he launched his own mission, the Sukhoi mission, around 2,000 years ago, governments around the world believe there are huge benefits to being a part of the craze. The participating countries may fall behind to some extent. As Indian Space Research Organization chairperson Krusha Swami Moon 15 Kazurangan said, "The question is not whether we can afford such an explorer. The key is whether we can ignore his importance." Russia is determined not to be left behind by its competitors. In fact, he was earlier than his competitors in considering new exploration missions. Back in the mid-1990s, Russian scientists Mikhail Marov and Eric Galimov has given his support to the newly formed Russian Space Agency. Roscosmos offered their suggestions. Their Lunaga project was approved. The original plan included more components, such as the penetration period for seismic detection, landing stages and orbiters. However, initially, the project did not receive sufficient political support. After the 1998 Russian financial crisis, the ruble has depreciated by more than 2/3 in 3 years. Russia is facing budget cuts. The project was rejected many times. Penetration period and orbiter canceled. Only the lander remains, because the mission plan was redesigned. In order to make it more economical, Russia aspires to become a global player in space exploration. I didn't want to spend a huge budget on it. In 2005, Russia invested only 20 billion rubles in the space industry. The U.S. investment is as high as $15.60 billion. One solution is to cooperate with other countries. Russia first tried to cooperate with India in 2007. Joint execution of the Vietnam Ship 2 mission. Luna 25 is scheduled to launch with India's orbiter and serve as a lander for the mission. However, due to insufficient funding, Russian scientists failed to resolve the underlying issue of anger ahead of the launch date set in early 2030. India has finally decided to complete the Sukhoi 2 mission alone. Russia then attempted to independently complete the Luna 25 mission, send it to the surface of the Moon. Although India's Sukhoi 2 crashed on the Moon upon landing, but India is still eager to try again with Sukhoi 3. This has turned Russia and India from partners into competitors. Russia and India are both interested in the lunar South Pole region. There were spectral measurements to confirm the presence of sailors. Luna 25 in Changjiang. Sanjang Shizuka became the first probe to successfully land on the South Pole of the Moon, and may find sailors for the first time. However, Russia is facing new challenges. The Ukraine crisis in 2022. Western countries express strong dissatisfaction with Russia's behavior. They have joined forces to impose massive economic sanctions on Russia. These sanctions have dealt a huge economic blow to Russia. One of the key measures is a ban on trade in high-end computer chips and related components from Russia. This measure only hinders Russia's development of high-precision ballistic missile technology for military purposes, but it also poses a major obstacle to Russia's dream of landing on the Moon in the near future. The European scientific community has begun to end its partnership with the Russian space agency Roscosmos. In today's globalized world, Russia relies on international trade for a large number of high-end technical components. And now Russia has to face this challenge alone. At the same time, India completes preparations for the July Ship 3 mission and launched on July 14, 2023. The orbit of this mission is designed to save fuel. Although this sacrifices time efficiency, it actually takes more than a month to reach the lunar surface. India's expected landing date is August 23rd. If Russia can step up its progress, make its powerful Soyuz 2.1 drop rocket pass through a shorter routes with higher fuel consumption, it is possible to complete the launch of the landing period and reach the Moon before India. The Luna 25 mission was originally scheduled for 2021 launch and delisting to 2022. Postponed again to 2023. What is not? The Russian navigation sensor failed the quality inspection. The design of this sensor relies on computer chips usually supplied by Western countries. Affected by Western sanctions, Russia cannot purchase these chips. Therefore, they had to develop their own new Boson navigation system. Earth 25 is finally ready on August 11, 2023. Launched with 8 Russian Imperial examination instruments. These instruments include the Laser Compact Meter, red and white spectrometer, a camera for imaging the lunar surface, and devices for measuring dust and microfluidity. Luna 25 is scheduled to spend a year on the lunar surface. Will withstand the extreme cold of the moonlit night and the intense solar radiation of the lunar axis. It has the potential to conduct important scientific research. With the help of the powerful thrust of the Soyuz rocket, Luna 25 is expected to reach the lunar surface by August 21st. Arrive 2 days ahead of the Indian lander. This means that Russia has the potential to win this competition with its competitors. Badminton 25 was successfully launched from the Orient Cosmodrome on August 11, 2023. It successfully entered lunar orbit on August 16th. He photographed the surface of the Moon. In particular, detailed imaging of the stuffed crater. All systems are functioning normally. Good commuter connection to the Earth. Then Russian scientists began to make final preparations around the road. Due to the complex topography of the lunar South Pole region, scientists hoped to avoid a rough landing, to avoid damage to Luna 25. But then something went wrong. On August 19th, Luna 25 has lost contact with Earth. He no longer accepts remote instruction. They try to execute a pre-programmed maneuver, thus entering a new track, preparing to land on the lunar surface, and then the clapping happens. On the newly developed Boson navigation device, this device was developed after the previous navigated device failed quality control tests. He sent the wrong message to the space-grade control unit. Due to the overwork of the thrusters, lasting 127 seconds instead of the planned 84 seconds, Luna 25's descent has become unusually steep. On August 20th, the probe has rushed towards the lunar surface at an uncontrollable speed. The scientists at the Russian Space Agency were at a loss. Only watch it crash into the moon. It's getting faster and faster. Although no external cameras captured footage of the impact, but it's not hard to imagine, due to the acceleration of gravity, how Luna 25 unfortunately became a veritable lunar coffin. His mission was far from lasting a year. It ended in just a few days. NASA's Lunar Reconnaissance Orbiter then passed through the region. The rest of the Luna 25 crash was filmed. Luna 25 created a nebula crater about 10 meters in diameter. Russia attempts to prove to the world with Luna 25. Despite facing serious challenges, he remains a powerhouse in space exploration. However, the failure of Luna 25 highlights the pressures and challenges facing Russia. Western sanctions indirectly contributed to this failure. Russia's replacement chips are not accurate or robust enough. It cannot operate stably in the harsh environment of space. In the process of trying to leapfrog rival India, Russia poses problems for itself. Learning that he planned to arrive 2 days earlier than India, I can't help but think of a scene from the past. The Soviet Luna 15 mission crashed just a few hundred miles from the moon. The same day that Apollo 11 landed. The purpose of the Luna 15 mission is to collect lunar rocks, just as the Apollo 11 astronauts did. Although Luna 15 is unmanned, but if the American mission fails, the success of Luna 15 could have been Sulai's pride. Capture America's thunder. This is undoubtedly a political score. Russia's goal is not just to land on the moon, but to be the first country to arrive. When you're trying to get ahead of the competition, inevitably, less time is spent making sure everything works. This increases the risk of failure, like the fate of Luna 15. Luna 25 also had the opposite effect of what the Russian leadership had expected. He failed to demonstrate Russia's leadership in space exploration. Instead, it highlights the drawbacks of isolation and competitive cooperation. If Russia can continue to cooperate with institutions such as ESA, shared basic progress might be able to celebrate its success. In many ways, it's a tragedy. Maybe one day that will change. Our future seems to point to the stars. If we are to thrive in the universe, and that's because we're all working together as one planet. The tragic fate of the Luna 25 mission should be a valuable learning experience, and not just an awkward protagonist in history, but only if we can learn the right lessons from it. Pride is not always a good thing. Competition can sometimes lead to unnecessary isolation. They cloud our judgment. It's unlikely, but if we stop trying to prove each other's superiority, that would be a good thing.